Hi guys, today we'll talk about Lami's theorem. So this theorem was proposed by Bernard Lamy. So first of all, what is this theorem? So this theorem says if three forces are acting on a body and the body is under equilibrium, then the forces are proportional to the sine of the angle between the other two forces. This theorem is applicable in statical mechanics. So statics and mechanics. In the previous video that you have seen, you might have seen. I've shown you a small setup here. So I took two different strings. So let us say the forces in these two strings as P and Q, and the weight of this object that I've added some weight W, which is obviously acting in the downward direction. So this weight is actually creating tension in these two strings. Okay, so that is what I've represented here as P and Q. So I've told you you guys might have seen situations that I've shown to you. P, Q and weight, which will obviously act in the downward direction. And now again, if we consider the second scenarios or second case, let us take this one as in theta 1, theta 2 and theta 3, theta 1, theta 2, again this one as theta 3, and so this one as the second case. And now lastly the third case. So this is the force P, Q, and this one is the theta 1, theta 2 and theta 3. If you observe them closely, as I'm changing the position of the weight, okay, the angles are changing, right? Theta 1, theta 2, theta 3 are changing, right? So as these angles are changing, the values of P and Q are also changing, right? The weight won't change, it will remain the same, but the values of P and Q are changing, right? So which means there is a relationship between these angles and the forces. That is what Bernard Lamy found. Okay, so what does he actually found was, suppose if I take P force as an example. See, I'm telling you guys this thing. You can relate P with theta 2 and theta 1 also. Just because Lamy said something, okay, that doesn't mean that only you can relate P and theta 3 only. You can relate theta 1 and theta 2 also. But whereas it is very much complicated. Okay, so let us see what he is actually saying. So here, if P force is acting like this, then the angle between Q and W3 has to be considered for proportionality. So as this angle is changing in terms of sine, which is actually proportional to P. Say something like some P values initially some 10 Newton of force in the upward direction, and sine value say something like some 0.2. If the sine value becomes 0.4, then the P value will become something like some more greater than 10, somewhere around some 20 Newtons or something. That is what Lamy found. Suppose if you consider Q as an example, so if in this Q string, Q force, along Q force, say there is a 50 Newton of force which is acting. In terms of sine, if it is some sine value, say something like some 0.1 or something, if the sine angle, in terms of this angle, if this angle was changed, okay, say something like some, in terms of sine theta 1 now became 0.2, then this will become somewhere like 25 Newtons or something, more than 15 Newtons, because these two should be proportional. The sine of this angle is proportional to this force. That is what Lamy found. So now if you want to represent them, in some equation form, then say this is theta 1, say this is theta 2, and say this is theta 3, then P will be proportional to sine theta 3 and Q will be proportional to opposite angle between these two forces is sine theta 1, and W will be proportional to sine theta 2. Okay, so if these are proportional, then we can eliminate them by using certain constant, right? If so, then ultimately they will become sine theta 3 Q by sine theta 1, and similarly W by sine theta 2, likewise. Okay, thank you. So if you want to, this one should only be applied to the bodies which are in static equilibrium only, static equilibrium. Okay, so when the causes and effects are getting nullified, which means the forces and reactions are getting nullified, and the body is said to be in static position, then we will say that the body is under static equilibrium. So suppose if you consider this sketch as an example, right now this one is giving a force of something like some 5 grams or something, and a force of some 0.2 newtons or 0.1 newton in the downward direction, and it is also getting a force of 0.2 newtons or 1 newton in the upward direction also. So that's why it is in static position. So that is what static equilibrium means. So right now this one is under static equilibrium. Okay, so whenever there are 3 different forces which are acting in on a body which is under static equilibrium, we can apply this Lamy's theorem. So using just by this Lamy's theorem can simplify a lot of problems. Okay, because this is a simple equations which will relate 3 different forces. Okay, just by using the sign of the angles between them. Thank you.